Daniel, welcome to Stemiverse.
Thanks. Nice to be here.
Good to have you on. I've got to say that this is the first podcast interview for 2019, and a real pleasure to have you on because we're going to talk about robots, robotics, and education, which are two of my favorite topics. As always, I'd like to invite you to tell us a few things about you, about your background as a person, as an engineer, and then we'll dive straight into technology and education.
Sure. I don't know. Do you want me to go in chronological or reverse chronological order?
You can start, okay, let's make it a bit more specific. When
Sure.
did you first felt the need to become an engineer?
Oh, as long as I can remember, I think I've always been an engineer. I know for a fact that my mom has boxes of the little paper parachute men that I made when I was 3 years old out of paper and tape. And it's from then on, I've always wanted to do engineering, and I've always wanted to do robots specifically. The thing that is really enchanting about robots is they're, to my mind, it's magic that actually works. Because what does a wizard do? A wizard takes an idea and they make it real and make it operate off on its own in the real world. And that's exactly what a robot is. It's the only way I know to actually do that is that you take your ideas, you put them in something, you do a lot of work, but then you have something that you thought up that actually goes off and on its own accomplishes something in the real world.
Independence. But from paper parachutes to robots, it's quite a continuum, right, between the one. It was something like an episode, something you saw, something that somebody said back then in your early
years. I honestly don't remember. I've always wanted to do robots. I mean, so I've had a pretty eclectic education. I was actually homeschooled all the way up through college. Then I went to Lawrence University in the Midwest United States for college, got a bachelor's degree in physics, which as an electrical engineer has turned out to be really useful because it's surprisingly few how many people it is who actually understand what happens inside of a transistor. We like to pretend everyth's digital all the time, but it isn't. Everything's actually analog. The world is still analog. So that's been a valuable lesson. And Lawrence is also a liberal arts school, which was great for my education because, they really emphasize learning to communicate well there. So, spent a lot of time improving writing and other communication skills there. Then I went to Rensselaer Polytechnic Institute in upstate New York, got my Master's of Science in Computer and Systems Engineering, working on the intersection of mesh networks and mobile robots, which was a sort of an interesting project. But by that point, I'd had about enough of academia. So I went off and joined a startup company trying to do human-sized telepresence robots, which is telepresence. So, having your own robotic avatar somewhere else in the real world instead of just doing static video conferencing is still something that I firmly believe in, but there are so many technical challenges that make that it doesn't seem like it should be so hard, but it is. So someday I still hope for that, hopefully before jetpacks. And then, that was a startup experience, which is fun because I got to wear a lot of hats. I was the fifth person there. So that was from 2008 through 2011. That was a startup. It was great, a little bit high stress. So I needed a break after that. So I went and worked at Sandia National Laboratories, which is, it's one of the United States government's national laboratories. It's about as far from the startup experience as you can get, which was a nice break, but I still wanted to do something entrepreneurial. So while I was there, I co-founded, along with Andra Key, who I know has been on your podcast before, Robot Garden, which is what we believe is the world's first robotics-focused makerspace. That was out of a desire to be doing something more entrepreneurial, desire to be doing more with robots, and just more building things. Makerspaces are awesome, and at the time there were already dozens of them in the San Francisco Bay Area, but they were all about an hour and 15 minutes from the East Bay, where Andra and I lived. So we wanted something a little bit closer, and rather than, no one else was doing it for us, so we decided to just do it ourselves.
That's it. Just make it happen, like our true maker.
Yeah. So so we founded that, and so I helped run that for a couple of years. It's still running today, actually, with new people taking it on, which is always great to see a nonprofit organization outlast your involvement in it. There's plans for the future there. But my day job now is working at Anki, which is a consumer robotics company, doing AI and robotics for home applications. That's sort of an interesting challenge. It's one thing to make one robot and another thing to make millions of robots and make them to a high enough quality that regular people will actually find them useful.
Wow. Don't know where to start because it's just covered so much over the last couple of minutes. And a lot of it, actually, I want to get into it. Like, for example, let's leave Robot Garden for a little later because it contains a strong educational element that I want to touch on. And it's unique in the sense, as he said, that it's focusing on robots plus education. I guess that's the intersection for Robot Garden, and see what we can learn from it. There's Anki, of course, that I want to have a look at as well, because I did spend a lot of time looking at the videos on your website and the various bits of information that you have, and looking at the robot models that are available to buy from pretty much any store here, including here in Australia. You don't have to go too far. I wanted to look at the fundamentals, so maybe rewind and just to explain what is a robot and how a robot differs to general automation, like, a system that can turn the lights on and off, or my automatic gardening system that it does have the ability to sense and do things. Is that a robot, for example, perhaps a very simple one, or is it something special about robots?
So I don't know if you'll find this answer satisfying, but the one I always go to for the definition of a robot is that a robot is an electromechanical device that doesn't work in demos.
Right.
Because, it's kind of like the definition of AI in computer science used to be the set of computer science problems for which no good solution is known.
Right. So it's a general category then where all that fits, something that is
it's the frontier. So once something is reliable, we start calling it an appliance, right? Your oven, there's sophisticated ovens that know when, where you can put in, tell it, I'm cooking a pot roast and I want it to be done at 5 p.m. And it works out when to start and how long to cook it, and takes care of everything for you. Is that a robot? Well, no, it's not. We call it an appliance because it works too reliably. Show a dishwasher to, a modern dishwashing machine to anyone from 1950, and they would call it a robot, but we don't call a dishwasher a robot.
It's like a moving target then, like our expectation is that a robot can make decisions, there's intelligence in there, but as soon as we understand exactly how it works and we can predict it, then it's not a robot anymore, right? It's an appliance.
Yeah, I think that's certainly been the case for a while. I think we might be getting to a point where we have a new class of robots, where the robots might be defined by how you interact with it. So, you have a very transactional machine interface to a dishwasher. You push you load it up, you push the button, it goes. You don't have a conversation with it. It doesn't come and tell you things. But it still thinks, sense, and acts. The more useful definition of robot in the future might be more about the way they interact with humans. And so we talk about human-robot interaction design. One of the big things at Anki is the need for robots to have emotional intelligence. because in order to humans are emotional, we expect other beings to be emotional, and we actually have an easier time understanding them if they are.
Right. I think I understand the distinction that you're making now. A dishwasher, although it may contain intelligence to make sure that the outcome, the dishes are perfectly clean at the end of the cycle, it can't read my expressions. It can't interact with me at a more human level. But what we call a robot, whether it's like the Anki robot, for example, that is on wheels, or it's a humanoid robot like Asimo, right? The Honda robot, which can walk on two, it's bipedal. Both of those things can read our expression. So they've got the intelligence there, but they also have the ability to visually recognize me as perhaps the owner or the person standing in front of them, and then use human modes of communication like language and facial expressions. And that makes Anki a robot and the dishwasher an appliance. Would that be fair?
That's certainly part of it. I mean, Anki is also in sort of a special position where, we're selling things to people who want to have things called robots. Right. Like, so it's, to a certain extent, it's a robot if you want it to be a robot.
Right.
Right.
If we like, there's another thing. So I was talking to my father yesterday, and I was trying to understand the misconceptions perhaps, or misunderstanding of how technology is evolving today by, I guess anybody who's not a roboticist is probably having similar trouble understanding what this technology is at the moment and how it's evolving. I guess, can you give us a range of devices and technologies that are called robots by the people that actually make them? And I'm thinking here, say, industrial robots, which all they are is like a robotic arm with, I don't know, 5 or 6 degrees of freedom that can pick things up and put them in the right place. And we call that a robot. And we've got cars that are becoming intelligent and able to drive themselves, like a Tesla self-driving car. We call that, I guess, a robot as well. Then there's Anki, which has got the ability to understand emotion in some way. We can talk about that in more detail later. We've got Siri and Amazon, Alexa, and software robots. We still call them robots, I believe. What is the common thread among all those?
In a lot of those, I think the common thread is actually the ability to interact with the real world is really part of it. The difficult thing in robotics is always how constrained your domain has to be, right? A dishwasher has a very constrained domain, right? It's literally a box, and it only cares about the things that are inside of itself. It controls almost everything. And so, you might load it up with different things, but it's not that difficult of a problem. An industrial robot actually has to deal, people often poo-poo industrial robots as being like, these are disappointing robots, but, they're really quite impressive. There's a lot of things that they have to be able to react to for safety. You have to notice when, the large robots assembling cars, they have load cells in their end effectors so that, if they try and pick something up and either they fail or, I don't know, the metal buckles or something like that, they know it doesn't weigh what it's supposed to weigh at this moment. Something has gone wrong. It's time to stop. And that trend in manufacturing is continuing to trying to get more towards co-working robots where it's safe for humans to be in the environment with them. They have to be able to sense things around that. One of the things I didn't mention in my background is I also worked for Miller Electric welding company for a while, doing arc welding equipment, and welding robots also. They are continuously sensing the environment that they're welding and reacting to it. And any time when you're interacting with a world where in traditional programming, is like you're programming a chess robot, or sorry, a chess program, right? It's like knight to rook 7. That always does the knight works that if the knight's in the right place at the beginning, it's always in the right place at the end. That happens 100% of the time. Nothing can possibly go wrong.
Yeah.
But if you're playing with a real chessboard and you have a robot arm, there's 1,000 ways that interaction can go wrong. And so I think the common thread in robotic technology is being able to deal with a real world where things don't always work the way that you hope they will. And that's true of industrial robots. That's true of robot vacuum cleaners. That's true of autonomous cars. Obviously, have to have fallback upon fallback of ways to deal with unexpected situations. Anki's robots definitely do, because we're interacting with people, in some cases children. There's a classic problem in localization. So like SLAM, simultaneous localization mapping. One of the classic problem statements is called robot kidnapping. So you have this robot. It's made a map of the house, and suddenly something happens, and it's moved from one place to another place. At Anki, that happens to our robots all the time.
Yeah, you just pick it up and
move it. That's from an academic standpoint, that's the robot kidnapping problem. But it's a problem that happens to us many times a day.
So the robot has to have sensors. Like it's the awareness that makes a robot, and a dishwasher. Actually, I should say increased awareness of its external environment. The internal thing is a given, right? The robot needs to know its own operational parameters, whether its hand is up or down, or whether its cameras are turned on. So I'd call that internal awareness. But then a robot has increased situational awareness. So it's got a lot of sensors looking at its environment, and it knows where it is in relation to other things in its environment. So would that single word help us understand the difference between a dishwasher and a real robot?
Maybe.
Part of it. Yeah.
I think the other part of it is being able to take appropriate action. Right. It's great to have sensors that can tell you whether you're in the environment you think you're in. Your refrigerator may have some idea whether it's inside or outside your house, because your refrigerator probably measures the exterior temperature as well as its internal one. But there's nothing it can do with that information.
Right. So what about a goal? So a robot has a goal. Perhaps it's a goal that its human operator has set for it, but it's got a goal, and then there's the actions that you mentioned that it needs to decide on with some degree of freedom to achieve that goal.
That's an interesting case. I might actually say that of things that people call robots, having a goal might actually be a count against you. One thing, this is maybe slightly tangential to what you're asking, but you look at a lot of robotics companies, and many of them fail by falling into what I call the platform gap, which is, I like building robots. I'm going to build an awesome robot, and it's going to be a platform that people are going to develop software for. And so somebody else is going to figure out what this robot's for. And then, that to this date has not worked out for any company I'm aware of. Which is not what Anki does. Anki, all of our robots have SDKs that allow people to write their own programs for them, but all of them come out of the box with a purpose, and some either game or utility that they fulfill that makes them valuable to people. And I think that's what makes them products.
Right. Yeah.
There's so many things that people like to call robots. They're just like, well, I don't know what its purpose is.
So
it's cool. But
in the case of Anki, it's a robot because it's useful out of the box. But on the other hand, there are robotic platforms that give you the tools, perhaps sensor arrays, programming interfaces, things of that sort, a bit of hardware that allow you to create a robot out of or build on top of the robot platform. And what you're saying, if I understand right, is that those technologies are commercially not that successful at the moment because I guess the education layer perhaps is missing, or something else is missing. Is that right?
No, because a platform isn't a product.
Yep.
Right. A platform is something that somebody else can make a product out of. I mean, with some exceptions. Obviously, Amazon is very good at Amazon Web Services platform.
The provide
Uh,
platform. Yeah.
right, but that's a very well understood situation where it's clear what you need.
So it's a frontier, in other words.
Yeah, hardware is not the same world. In order to have a robot that is functional and cost effective, it needs to have been designed for a purpose.
Right.
Uh, iRobot makes multiple, they make a mopping robot and they make a vacuuming robot, and they don't look anything alike, right? I mean, they both have motors and wheels and sensors, but they're not, it's not like they have one sort of home cleaning robot platform. Even in
Mm-hmm.
that one company, they don't have one home cleaning robot platform and then they have two versions of it. It's like, no, this is the mopping robot, this is the cleaning robot. These are different things.
Well, it seems like it's the age of exploration when it comes to robots because the technology has advanced. So now we've got Internet of Things, which means like Amazon mentioned Amazon. It
Mhm.
provides a platform where IBM Watson, where you can tap on extraordinary amounts of codified knowledge that your
Mhm.
robot can use to make decisions about the world. And those are platforms as well. But then on the other hand, I see robots of all shapes, all kinds, all sizes, like robots that walk on six legs, that
Mhm.
fly, that go in space, that go underwater, that dig in mountains, that live in cyberspace only. So all the situational awareness is inside cyberspace, inside the internet. There's like an incredible array of variation in robots right
Mhm.
now. And I wanted to ask you, like, from your perspective as a roboticist and entrepreneur as well, what do you see as the frontier right now, if there is one frontier, right? What is the cutting edge of robotics, or perhaps the problem that is like a holy grail that if you solve that robotics problem, then you go up to the next steps, like going from analog mobile telephony to 3G or 4G. Is there something like that in robotics?
Um, I actually, honestly, personally, I don't think there's moments like that in any technology.
That's Einstein, sorry. That's a dog.
I mean, sure, there are moments of discovery where you find something new, but all of them take work,
Hmm.
and all of them. I mean, there's been very few developments. I can't think of any example that has led to instant change across an entire industry, right?
Maybe
Um,
it's more theoretical. Like I'm thinking, something like in physics, the boson particle, for example. You've set up a whole lab in Switzerland,
mhm.
accelerator, to try and find that one thing that's predicted by theory. And then now that we've found it, well, okay, that helps us, build the next unifying theory in physics. Is it something like that in robotics?
I mean, I think there's a whole series of them. So when I was in school and starting to do robotics, the big problem was sensing. There just were not good enough sensors.
Mm,
Um, the so many of the problems. I mean, the reason why the robotics part of my master's thesis was done pretty much done as a toy problem was that truly sensing the environment was just plain too hard, right? Like you could maybe get some sensors that would do it that would
yeah.
uh, be cost $10,000, and then you could have one sensor and it would help you a bit, but it was just too hard. Think back to the drone revolution.
Yeah.
The thing that enabled the drone revolution was cell phones, right? That's why the technology became possible. It used to be that an IMU cost $10,000 and
Yeah.
wasn't as good as the IMU that costs 10 cents today.
Today, yeah.
And that is an absolute, so that is the kind of thing that it didn't literally create an industry overnight, but the fact that that sensor exists did enable a whole new set of technology.
Yeah.
Cell phone processors in a very similar way have enabled a lot of new technology, because you take in the computational power that used to be in a server and put it in something that fits in your pocket and runs on a battery.
Yeah.
That the cell phones have actually probably been the biggest help, or smartphones, I should say, have been the biggest help to robotics in my career. The other one is, of course, like I said, sensing. So there were back in 2010 when I was working on telepresence robots. We could get 1 degree of freedom lidar that would give us one slice of the world, and that was what we could get at still kind of an expensive price point. And now you can get chip time of flight sensors that give you a 2-dimensional depth image, or takes an image of the world in 3 dimensions. And just gives you a vast amount more information. And those cost less than those 1D LiDAR scanners used to, and uses less power and is smaller. So sensing is a huge part of it. If I had to place a bet as to what the next enabling technology for robotics is going to be, I would actually probably say battery technology.
Yeah.
Because actually doing things requires energy. And unless you can come up with an application where it's okay for your robot to sit on the dock most of the time, and there certainly exist applications like that, then battery life is going to be a big deal.
Yeah, because robots tend to become more autonomous over time, right? Like the Anki robot needs to be able to move around. It won't be very practical to do that if it's tied to a USB cable or power point.
Yep.
So batteries.
Yeah, and then computation is still a thing that's getting better. I think that the smartphone processors have improved things. Moore's law is not really keeping up exactly anymore, but at the same time, we are still finding ways to use things like GPUs, and there's still improvements there. Certain algorithms can be moved there. Deep neural network processing, which is sort of being lumped into the AI buzzword these days, also makes a big difference. But I think it's still too early to know.
Specialized hardware to assist the robot in making, I guess, faster and better decisions in specific areas, like visually recognize an object, or learn something through a dedicated neural network, perhaps. So those are now can be implemented, specialized hardware, in order to deal with the problem of Moore's law slowing down. Right. That's great. From what you say, what I understand is that, as expected, in engineering, a lot of things have to happen in order to get a single product that works, that solves a problem or multiple problems. It's not a matter of just a single breakthrough that transforms the industry, although that may happen, but it's very rare. It's like the internet only evolved once, right? And the transistor only evolved once. And it does happen, but it's rare. I wanted to switch to Anki now, because we've got like a robot that you played a role in building based on everything that you've learned and all your experiences. And at this point in time, it's accumulated to a robot. So can you tell us what makes Anki, there's a few models, you can tell us about them if you wish, what makes Anki different to other models? And while you're talking, I might share my screen.
I'm sorry, different from other?
From other robots. What is special about it?
So I don't know, other robots is maybe too broad category.
Don't worry about it. Just focus on.
Let me talk about what makes Anki different is I think our approach, which is Anki is a very tightly integrated company. We do all of our own engineering. And we have a really broad team. It's the only place I've ever been where you can walk around the building, and you can meet people who's spent a career doing toys, people who've spent a career doing consumer electronics, people who've spent a career doing animation. People who've spent a career doing video games, and all of these different fields are coming together to make our robots. Vector is our most recent robot, which is a home utility robot. Just to give you,
It's very small, right? I can see this
yeah,
picture compared to the, yeah, it's tiny.
yeah. So there's a couple of reasons why it's small. One is that being small makes a lot of things easier. It's like I said earlier. Being a successful robot right now is all about having a sufficiently constrained domain. Anki's first product to market that was called Drive, and that was a racing game where you had these little cars that were about this long, 2 or 3 inches long, running around on a racetrack, and you can control them with your phone. But it was all app driven, and the game knew where the cars were and knew how the cars were interacting, and so you could have both some of the cars be controlled completely by the game rather than by another player, and also have virtual interactions between the cars where you shoot a virtual gun from one car to the other, and then the game causes that car to simulate being damaged. But that was a sufficiently constrained area that at the time we could take it on. It's cars on a track. Then Cosmo, we broke that a little bit more and made it a tabletop game playing robot.
Mm-hmm.
And then Vector is the next step beyond that, where it's really intended to be a robot companion that is something that you have around the house, that is just nice to be around in the same way that a pet is, but also you can use it for utilities like checking the weather, setting timers, etc. And you can play games with it.
Yeah, I like how you've got a blackjack app, which are my first mobile phone. It was a Nokia. I can't remember the model, maybe 3210, something like that. It had a very simple game. I think it was Snake on it. So it was one of the addictive features of those early technologies, the mobile phones. What, like, you are space age engineers, and you've got here like face recognition technology on this tiny robot, and then you put blackjack on it. What was the decision behind that?
So the reason we put blackjack on, so when we were trying to decide, Vector is a platform that will grow. Let me actually go back a little bit to mention one other thing with being small, which is, being small makes it non-threatening is part of it. People are definitely concerned about robots, and industrial machines certainly are scary. But being small makes it non-threatening, and means that you can pick it up and move it around. But also it helps us set a expectation that we can live up to. I haven't actually seen any research on this, but I have a personal theory that people generally peg their first expectation of the intelligence of a robot is based on animals they know of that are about the same size.
Right.
So if you make a robot the size of a gerbil, it only has to be better than a gerbil to be impressive. If you make a robot the size of a person, it has to be as good as people expect it to be as good as a person. And that's not an expectation we can live up to.
So it's going to grow in size, if you understand what you're saying. As its intelligence is growing, its capabilities grow, then obviously you'll be able to increase its size to do more things.
Yes. And, as its capabilities increase, it'll also it will need to be more sophisticated, and have more ability to interact with the world. And it'll be worth getting bigger.
So what I see here, you've got a couple of pages. The first one is just an introduction to the robot, and it shows some of its capabilities out of the box. So you can talk to it, and you can ask him. So it's a boy, apparently. You can ask him about the weather, and it will tell you. It's got a speaker. You can ask him to set a timer. It will do that and take photographs, play blackjack, and there's a bunch of other things here. So it's got a calendar. It can tell you about what's up ahead. But then you've got another page for developers, And that's where you talk about the software development kit that without needing a PhD in robotics, you can actually get Anki, which one is this?
So that's Cosmo. There's another page
This
for
is
the Vector
Cosmo.
SDK, but
Sure. It's
yeah.
okay. You can get one of the Anki robots that is compatible with the SDK to do unique, implement unique capabilities, right? And you can use all of its sensors. So there's vision, like there's camera, there's cameras,
Yep.
microphones, location sensors, I guess, and lots of other things. You can program it in Python. Like, what are some of the amazing things that people that you know about, like your customers, have done with Anki in education? Doesn't have to be education, like in any field, something that you are really proud of that somebody has done with your robots.
So with Cosmo, one of the things that was sort of the most surprising is that people use the SDK to make Cosmo into an actor. And there's quite a lot of YouTube channels out there with videos starring Cosmo. And they're
Cosmo
using
is like placed in a movie, right? And the programmer or the director will write the script for Cosmo, and then Cosmo will just play the role, right?
Yes. So that was an interesting surprise. We've got people are doing all kinds of different things with it now. It's great to see it in classrooms. I've been so in addition to the Python SDK for Cosmo and Vector, Cosmo also supports a block-based programming language directly in the app now, which is great for younger kids. And you think about things like Scratch. It's one thing to make a little kitten move around on the screen, but it's actually even if it's from a programming perspective exactly the same thing, it's way cooler to make a robot move around in the real world.
Yeah.
And then besides that, we've in both the Python SDK and the block-based programming, we've given access to high-level functions. So you look at most robotic platforms out there, there'll be a function for like get a frame from the camera. But we have functions for things like tell me the XY coordinates of any faces in the frame that you can see right now. And then another function like
how many
face.
people in this frame, or can you be more granular? Can you say find an object, give it a sample like of an apple, for example? Here's a sample. Can you find anything that looks like this apple in this frame? Like, how detailed can you get?
So for Cosmo specifically, the SDK is based around the things that Cosmo understands. So Cosmo, we give you an API to get the raw data if you want. So if you want to get the raw frames out of the camera and run them through your own, say you do actually have a PhD in robotics, or even just really like tinkering, you can get the raw frames and you can run them through your own neural net processing or whatever way you want to do it, and recognize apples. But for the things that Cosmo just understands from our engine, which are basically faces and the cubes that come with the robot, we give you very high-level functions. So for faces, you can see essentially where they are. For the cubes, you get things like you can get the exact 3D pose of the cube. And then we give you access to things like path planning, so you don't have to know how to turn the motor specifically to drive along a smooth path. You can just say, I want to drive over to this position relative to the cube, and the path planner that's in the engine will just take care of all the details for you. And you can do much more. You can get into writing those sophisticated behaviors. Yeah, there's also pet detection.
Pet detection. Yeah. As you're talking, I'm going through your SDK here. I'm looking at the API. It's very interesting. Like I did not expect to see this as part of the SDK. So you have anticipated that people, just like, YouTube, people put the dog videos and cat videos.
Mhm.
This is a very important driver of technology. So there's a pets class with
Yep.
thought functionality here that you can detect Einstein, for example, the dog, and it's amazing. So, and this is, what would you say in terms of generation? Is it like the second generation of the SDK? Because like it
So we
evolved.
actually, yeah, so we actually released the Python SDK first, and then the block-based programming.
So version 2, 3, yeah.
Yeah.
SDK version 1.48.
Yep.
Great.
And Vector has a similar SDK.
So I don't know if you can comment on this.
Mhm.
It could be proprietary information for Anki, but like what is in your roadmap in the next 2-3 years in terms of how these robots will evolve and what kind of features might they have, to take us to the next step of this evolution?
Well, so the existing robots, we're going to continue improving them. So the latest release of the Cosmo app, for instance, because we saw that because it's an emotive and an expressive robot, people wanted to use it for those purposes. We released a variant on the block-based programming language specifically for making Cosmo act out stories.
Mm-hmm.
So that's one of the things that we just released on there, and we really use the block-based programming as a showcase in Cosmo, where some of the games that you can actually play with Cosmo, are written in the block-based programming language, and so you can play the game with your robot, and then you can look inside and see how that game was made.
Right. So we
Vector
can
is
learn. Yeah.
Yep. Vector is, it's a cloud connected, always on home robot. So, it's going to continue to get more utility features. It's going to continue to get smarter. You know, one of the things in the one of the recent updates we just did for Vector is the vision system now recognizes hands explicitly. Um, you know, people are actually really difficult to understand as a computer vision problem. It's we're not just spheres of a uniform color, or 2D barcodes or anything like that. So now Vector understands hands when he sees them, and can interact proactively with hands.
Like go this way, like if you say,
We don't have full gesture, but it's before it only recognized people in the scene as faces. Now it recognizes people from faces or hands, and so if it sees a hand, then it knows there's somebody nearby. There's kinds of interactions to do with that.
yeah.
And I've seen it do some really cute things, like I have Vector on the table. I happen to put my hand down, and Vector drives up and taps me on the hand, and it's just sort of a really nice little adorable moment.
Did you expect that? Like, was it part of his programming that you had put in there, or was it a little unexpected?
So I had to ask the guys on the behavior side. I'm in the hardware team, so I don't really do behaviors myself, but yeah, yeah, it is actually an interaction. Like when he sees a hand that he can get to go up and tap on it.
Right. It's like
But
with my
there's
dog.
lots of emergent behaviors as well, that you don't really expect. So Vector's only going to get smarter. More utilities are going to be available. And that's the way that's going. And then Anki in general, we are an AI and robotics company. We started in toys because that was a domain we could actually tackle, but we have every intention of making ever more sophisticated and capable robots.
Yeah. So don't forget I think the prime directive or Simov laws, the 3 laws of robotics.
Yeah, so those are nice laws for a science fiction author and terrible laws for a programmer.
It's like Tesla is having this problem right now, and other autonomous car manufacturers they have to deal with those issues. But I guess that's questions for another podcast episode.
Mhm.
Just as a last comment, I'd like to switch to Robot Garden for a few minutes,
Mm-hmm.
but as a last comment, I'm thinking that if you, or through your SDK, like I can see it's possible that you can integrate different artificial intelligence platforms, like you can
Mm-hmm.
connect an Anki robot to IBM Watson and then tap on
Mm-hmm.
that amazing capability there. So that would just another exponential increase in
Yep.
capability for the
And people have
tiny.
done stuff like that. Yep.
Yeah, I'm sure. If it can be done, it will be done, somebody said. And it's probably already done. If it just occurred to me now, somebody has done it. So awesome. Thank you for all that. I'd like to switch to Robot Garden now.
Mm-hmm.
And like in past episodes with other guests, we spoke a lot about makerspaces and things
Mm-hmm.
that you can do there. Makerspaces, as most of us understand them, like a place where you can find making equipment like 3D printers and um, um, uh, stations for assembling electronics and education components. Of course, we had in one case we had a guest who spoke about a biology
Mm-hmm.
makerspace in New York. Um, in your case, Robot Garden is a makerspace, but the focus there is on robots. So could you tell us a bit about it, the inspiration behind it, and some of the results you're getting, and why robots only? Why not, a general makerspace that also
Okay.
does
Yes.
robots?
Yeah. So let me clear that up. So
Sure.
the reason for robots is, the people who were there at the beginning, we were particularly into robots. That's what we wanted to build, and it seemed like a cool way to get started. Robots attract attention. They definitely do that. And for me, education was very important to it as well. And I've always thought robots are a really cool way to get into education. But then, when you say robots versus general purpose, well, think about what you need in order to build robots. You need electronics, and you need mechanical engineering, and you need human-machine interaction design, and you need software. By the time you've established all of the things that you need in order to make robots, you've built up a lab that can build anything.
Aha, right.
Um,
So, like, robot is a great tool or a great excuse, I'd say, to learn all sorts of other things that eventually can lead you to building a robot or working with a robot.
yes.
So much that goes in it, right? Hardware,
Yep.
software design, um, psychology.
Hmm.
So, okay, yeah, I get it. I get it. So, uh, who started? Was it yourself and Andra? Was it, did you have other partners to begin with?
It was myself and Andra at the beginning, and then other people came in. We've had just like any other volunteer-run organization, we've had
Mhm.
lots of people running it. A gentleman named Tom Mangers, the current president, he's doing great things with it. Um, and the direction that we're moving is to try and be more of um, a STEAM education hub. Um, there's so one thing that may be different from Robot Garden from some of the other maker spaces you've talked to is it's always been a 100% nonprofit, 100% volunteer run. Robot Garden's never had any paid staff to this date. Though we always hope to be able to grow to the point where we can
Yeah.
change that. Um, but the um, one of the things with being a volunteer run organization is like all volunteer run organizations are always competing for volunteers. And education is particularly can be particularly difficult because there's it takes a lot of work to teach classes, honestly.
Yeah. Yeah.
Um, but the good
Absolutely.
news is that the good news is that there are a lot of organizations out there that are doing this, but surprisingly, there, at least in our part of the world, there aren't a lot of facilities that are there with the purpose of just making it easy for these existing educational volunteer organizations to have a space to teach classes, to have the resources like the robots and the 3D printers and so on to use. And so that's a big part of what Robot Garden is trying to do right now is be a hub for STEAM education.
So I can see here you've got events. The one I was just looking at, Girl Scouts robotic badges in January. That's tomorrow, right? A couple of days from now.
A couple of days.
And you've got microcontrollers on the same day. Microcontrollers, electronic special interest groups. So you are organizing a lot of events. So that's one of the roles or one of the ways by which Robot Garden operates. But you also have memberships. So what's a membership? Is it like a maker would like a space where, we've got all that equipment to use and pay an amount and access?
Yes,
how does it work?
Yeah, so our model has been that everyone is invited to come to events. Sometimes we have classes which are paid, which allows us to pay instructors, pay for materials, and generate a little bit of revenue. But in order to use equipment, you have to have a membership. So if you want to use Robot Garden owned fabrication equipment or Robot Garden owned robots, then at that point you need to have a membership.
Right.
And that is just to keep the equipment maintained and the lights on.
Absolutely, and the cost is also very low. So in an individual membership is $50 a month, and you do get a lot of return on that investment. I wanted to ask you, since you have the experience of starting a makerspace like this, what was your biggest challenge to begin with, and what would you have done differently, if there's something?
It's an interesting question. I don't think I could have. It's always nice to look back as 2020 hindsight and say, what would you have done differently, knowing what you know now? But I didn't, so I'm not sure I would have done anything differently.
If you were to do this again, like
do this again,
my first study was.
Yeah, I would probably try and start more in a club model. I personally have a tendency to just jump in and hope for the best. And so, we started as a makerspace open to the public, and have tried to grow from there. We started having open access hours for members and classes, and we basically just we didn't really do a soft open. We just got it, applied for grants, got some equipment, lined up some space that on a shared use agreement, and started running it. If I was going to start a makerspace again, I would probably try and start it on more of a club model, and build up a core group first, before opening it to the public.
Why is that? Yeah.
Just because I think it gives you a little bit of a time to get a solid footing.
Right.
Make sure that the equipment you have, all the ins and outs. On the other hand, because we started open to the public, that actually and with an educational focus, that gave us the opportunity to apply for grants, which funded some of our initial equipment purchases and actually funded a lot of our purchases over the years. There's upsides and downsides. It was definitely a wild ride doing it the way we did, but. Yeah. There's the website. I'm not actually sure if it's still alive. Hackerspaces.org, which is sort of a worldwide directory of hackerspaces or makerspaces. And one of the things you see on there is that there's just about as many different ways to make a makerspace as there are different makerspaces.
Yeah. It's interesting. I ask the same or similar question to everyone who is running our Makerspace and have interviewed. on Stemiverse, and I always get different answers,
Yep.
which goes to show that there's many different ways to sort of skin a cat or start a makerspace. So
Hmm.
yeah, hackerspaces.org still exists. Yeah, check it out. I've got a few minutes left, Daniel, and just have a couple of other questions to shift gears now.
Sure.
Like I was looking at your profile, and you sound like a very busy person, which I find very common among engineers. First, I want to ask you, what does your holiday look like, or your weekend?
My weekend is, spending time with my kids and working on projects around the house these days.
Yeah,
Um, one what I my long-term project is my family loves gardening. We have something of a small urban farm. I live far enough outside of San Francisco that that's possible. So, we have a garden, we have chickens, and so on. And um, that's a lot of work, but it's really rewarding. And someday I'd like to get into trying to make that a little bit more robotic.
yeah, automation.
Yeah.
Yeah, we've got a backyard here, and it's maintaining back in the front. Actually, we live next to the mountain, so the soil is so fertile that before you know it, like I thought I did the lawn last week, and now it's about this high, and the trees have got like full of lemons dropping on the ground. I've got to pick them up, and there's spiders everywhere, and that happens very quickly. So it's the reason I have to leave where I'm sitting now to go out and tidy up a bit. So that's definitely something we've got in common. How much of your your engineering background spills in other parts of your life, like spending time with your kids, for example? Do you tend to do activities that you wouldn't call them strictly engineering? Like, do you play Minecraft with your kids, for example, or do you do Monopoly or drawing something else?
Yeah. So it depends. My kids aren't really old enough for Minecraft yet, but they do love Legos, and I love doing Legos with them.
Mm.
They enjoy doing block programming with
Yeah,
Cosmo, for example, which is it's really nice when you get to work on something and have your kids appreciate it. Um, but you know. One of my daughters wants to be an astronaut, and one of them wants to be as far as I can tell, she's only 2.5, but she seems to want to be a veterinarian. Um, and my son is into his sports and but also into anything to do with tools. So I try and involve them in whatever I'm doing around the house, but it depends on what they're interested in.
yeah,
Um, everything I think they all have at this point an engineering mindset. Um, they where you look at something and you try and see is like, well, how can I solve this problem?
mm.
What's going on here? What what could I improve? And so
Actually, like because it happens with me a lot. I fix everything pretty much around here, so people tend to not try to fix anything. They just ask me to fix it for them. Is that something that plagues you as well?
probably not because, as you mentioned, I'm so busy. Unfortunately, I'm not around as much as they wish I was, and so that's been good for them learning to fix things themselves. Um,
Like, yeah. So not being
they
available is actually a good thing when it
uh,
comes to problem solving.
it can be, and one of the interesting things is the older ones are all obsessed now with the idea that they can find bugs in things. So whenever they play with Cosmo or Vector, if they see a behavior that they don't think is right, it's like, I found a bug. And part of it is, I think, just that they like that they can understand that this is something
Yeah,
that's made
yeah,
by people, and part of it's kids love to find ways to prove that adults are fallible.
absolutely. That's
Um,
great. Yeah.
and so
Um,
I've got a team of QA engineers.
I'm having a similar experience with my kids. I've got a 9-year-old boy and a 10-year-old boy as well. And, they're working on their computer or the iPod, and it could be playing a game or a drawing program or whatever. And if an element of the user interface, for example, a button is not descriptive, or it doesn't do what they thought it would do, or it crashes, for example, the application might run out of memory. You just blame the engineers. How could they let that go through QA? Like, seriously, we have to report this, we've got to go to the help desk. So they're really crazy about the quality of the technology that they use. When I was their age, I probably wouldn't make much of it. Of course, I didn't have any of that. But okay, the video recorder didn't quite finish the recording for some reason. Okay, I wouldn't think about what the engineers have done, but these kids can see the connection between the humans that design the software or the hardware and the end result and how they use it. It's the whole system. So the awareness is quite amazing, I find. Okay, I've got a couple of last questions, and
Sure.
yeah, we are pretty much on the hour with that. Let's see. Yeah, you're an engineer. So what application or technology you would be unable to live without? Something that organizes your life, perhaps, a tool that you use to get your work done, anything that you can't live without.
Well, it's sort of an interesting open-ended question. I really like the ability to, at this point, I'm very reliant on the fact that I can take an infinite number of notes on my phone or my computer, and I never have to worry about how many pictures I've taken or how many things I've recorded. Or this is like, I can just put it all in there and then I can search for it. And be able to find the thing that I did last Tuesday when I was in this, thus and such location. And it's all synced between devices and it's all searchable. And I think if I didn't have that ability, it would take a long time to adapt.
It's like perfect memory, right?
This is my, external brain. It's like all I have to remember is where I put the note.
So it's your
I don't have to
smartphone.
remember the contents. Yeah.
Yeah. It's very true. And, with robotics and robotic technology in the smartphone, I find I'm experimenting with Google Home now, and I've been using Siri and try to get, to become a power user with those tools. And it really can transform my productivity. Not the basic stuff, like just play music. Okay, no problem. Tell me what the calendar is, but the power user stuff can transform your productivity over time. So thank you for that. For anyone in our audience, and our audience at this point has a lot of teachers in them, but also a lot of makers, people that are interested in robotics, what is a good book resource for them to get started? With real stuff, not science fiction, but a reference book for robotics technology today for a beginner. Do you have something in mind that would you recommend to people interested in robotics?
It's a tough one. I'm trying to think off the top of my head. It's tough. I'm very much into hands-on learning, and robotics are sort of very much it's a hands-on industry.
So do it. Don't read.
So I would say, I would recommend either probably, I'm biased obviously, but Anki or Vector or Cosmo, or the Lego Mindstorm set is a big part of where I got my start with the original RCX. But then the newer ones are also amazing, and those are kind of fun because you get to build the robot and program it, and so you get to see some of the trade-offs that get made there, where it's like, well, it's easier to program if I build it like this, but I can solve this. It's hard to build like that, so I'm going to solve it in software. You get to see some of those trade-offs with Legos.
So hands-on learning, get a robot. Of course, Anki is obviously a very good option, but there's many others out there. See what fits your budget and the kind of learning that you want to achieve. Look at the resources, I guess, as well. That's important when you're getting started. So you want sample code, you want example videos, things like that, and see what fits best with your skill level.
And one of the things I'd recommend is making sure that you find something that has multiple levels of access in the APIs that it gives you. So that's honestly, I'm biased, but the thing that I think sets Anki's SDK apart is that you can do super high level stuff like turn towards face as one command.
Yes.
Or you can do very low level stuff like what is pixel 486 in this image? What color is it? And you can access it in
So,
any way. So you can start
right.
out doing implementing your own blackjack, or doing something that's very behavioral, or get into the nitty gritty once you're ready.
Right. So that's important, right? If you choose a platform or technology that only gives you low level functionality in its API, like giving the pixel
Mm-hmm.
where that object begins, instead of how many faces are in this frame, then obviously you're going to have a harder time to begin with
Yep.
at the lower level instead of the top level. But if you go the other way and you could choose something that has the top level and make sure that it gives you the continuity to go towards lower level functionality where there's a lot more power that you can customize and
Mm-hmm.
customize. Great. Thank you. Okay. I've got one more. What's your programming language of choice?
It depends. It depends on the application. So for me personally, it's either Python or C, depending on what I'm doing. And I use both. And I do mean C, not C++.
Right. The original.
Yeah. So
And why is that? Like C is very low level. Is that because as a
yes,
hardware engineer, you need to program at that level, right?
yeah. So C is low level. It is the if I'm programming on a microcontroller, there are microcontrollers I can program in Python, but and for hobby projects, I almost exclusively use Python because if I'm doing a hobby project, and it's a question, it's like, do I buy a $1 microcontroller that I have to program in C, or do I buy a $10 Raspberry Pi that I can program in Python? Well, those $9 are totally worth my time on the weekend.
Yeah.
Right, like there's no reason why for a hobby project I would ever use a low level language. For my professional work, no. Is like in order to make a real product that behaves reliably, that can be sold at a reasonable cost, it's like I need to be able to optimize everything down to the metal.
Great.
Um, but I will take that back and give the one caveat is if I'm doing a hobby project and I need it to be completely repeatable. And a very high degree of reliability, I will still use C because it is a more deterministic language.
Yeah. So I guess you need to use the right tool for the job, and a roboticist cannot rely on a single technology, right? As you said earlier, Robot
Mhm.
Garden is an example. Just to build a robot, you need all sorts of different technologies at the hardware and the software level, and even at the
Yep.
human level. And therefore, you had to become very skilled in many of those technologies, and including programming languages, even though you wouldn't consider yourself a programmer, would you? Like you're more like a hardware engineer?
Um, so I'm a hardware engineer. I spend a lot of time writing software.
Yeah.
Honestly, I
Because
probably
hardware
spend,
is not what it used to be. It's like
yeah.
software is connected.
So yeah, it's all connected. I spend a lot of time reading data sheets. I spend time doing systems engineering. I spend time doing programming. That's the role of a systems engineer is to be a little bit in all the different domains.
Well, and with that, I think we can end here.
Okay.
It was an awesome conversation. Thank you very much for that, Daniel.
Yep.
If people would like to get in touch with you or with Anki or the other projects that you do, what is the best way for them to do so? Are you on social media, email?
Email is definitely the best way to reach me.
Mhm.
Daniel.t.casner@ieee.org.
Got
And I'm
it.
sure you have it in the show notes.
We do.
Um, I don't always respond right away, but I will respond.
Be patient.
Yeah.
We need AI for my inbox that can intelligently reply to people instead of just saying, I'll get back to you one day. Anyway, that's a different story. Thank you very much, Daniel. And
Yep.
again, really enjoyed our conversation, and we'll talk again soon.
Okay. Thank you.
Okay.